Hello, boys and girls. Today we're going to be on page 13 of our probability packet, and today we're going to be looking at the probability of simple events. Now, a simple event is an event with only one outcome. So, for example, if I spin this spinner below, I'm only going to get one number. If I roll a dice, I'm only going to get one number. If I flip a coin, I'm either going to get heads or tails. There's only one outcome. Now, not all events are simple events. We're actually going to take a look at a kind of a more basic event that's not simple at the end of today. But our focus today is just simple events. So, just to remind ourselves, to find the probability of an event, we determine the number of favorable outcomes over the number of possible outcomes. So the first situation we're going to look at is spinning a spinner. Well, let's look at the spinner. How many outcomes are there? Well, there appear to be 8 different equally sized parts of this spinner. So how many outcomes are there? There's 8. And then we're going to list the sample space, which means what are the different outcomes that you can get? Well, you can get a 1, a 2, a 3, a 4, a 5, a 6, a 7, or an 8. All right, so let's look at some different probabilities that we can think about in terms of this particular spinner. So it says the probability of spinning a 2. Well, how many 2s are there? There's 1 2. And then how many total outcomes are there? Possible outcomes are there? There's 8. So the probability of spinning a 2 would be 1 out of 8. Probability of spinning a 1. Well, each one of these spaces is equally sized. So the probability of spinning a 1 would be the same as spinning a 2. 1 out of 8. The probability of a 2 or a 7? Well, if you either get a 2 or a 7, that's 2 favorable outcomes out of 8. Now, you can also think of that, if you were to simplify that, as 1 out of 4. Okay, that would be the simplified probability, but 2 out of 8 would also mean the same thing. Probability of spinning an odd number. Well, how many odd numbers are there? 1's an odd number, 3, 5, and 7. So spinning an odd number would be 4 out of 8, which again is equivalent to 1 out of 2. Now the last one is written a little differently, but again, when you have the capital P and then in parentheses the event, what you'd say is, how you'd read that is probability of rolling or spinning a 3 or a 6. There would be 2 favorable outcomes there, either the 3 or the 6 you could get. So that's 2 out of 8, which is equivalent to 1/4 as well. So if you were to pick any 2 numbers and say like a 1 or a 7 or a 1 and a 4 or an 8 and a 3, any 2 numbers would have a probability of 1 out of 4 or 2 out of 8. So the last question is a little different. It says, is this a fair spinner? How can you tell? When something is fair, it would mean that every possible outcome has an equal chance. So we would say this is fair. The spinner is fair because the probability of spinning each number is the same. So let's say that, all of them are equal sized except for 8. 8 was took up half the spinner. That wouldn't be fair because, again, 8 would have a much larger chance because it's a much larger space. Spinning each number is the same. But since each number has the same space on the spinner and it's the same size, that makes it fair. Each number is the same. Now, the probability of each one would be 1 out of 8, right? So you can kind of see that going around because, again, they're equal sized. So that would mean that they're all the same probability. So that would be fair. That would be fair. All right, let's check out the next example of a simple event. Rolling the number cube, aka the dice. All right, so how many total outcomes are there? Well, there are 6 numbers on a dice. So there are 6 possible outcomes. And then we're going to list the sample space, which is how many different, or what the names are of the different outcomes. Well, you can get a 1, you can get a 2, or 3, or 4, or 5, or a 6. So let's take a look at some specific events that could take place, and let's see what their probability is related to this dice. The probability of rolling a 6. Well, there's one favorable outcome there. That would be the 6 out of 6 possible outcomes. So the probability of rolling a 6 would be 1 out of 6. The probability of rolling a 2 or a 4, well, that would be 2 favorable outcomes, 2 or 4 out of 6. And again, we can simplify that to 1 out of 3. Probability of an even number. Well, if we look at 1, 2, 3, 4, 5, and 6, we have 2 is an even number, 4 is an even number, and 6. So there are 3 favorable outcomes that would be even out of 6. And we can say that that's equivalent to 1 out of 2, or 1/2. So we could also say that that's equally likely. It's equally likely to get an even number as to get a not even number or an odd number. The probability of a 10, well, there are no 10s. So there would be no favorable outcomes out of 10. So it'd be 0 out of 6. The probability of rolling a number greater than 3. That does not include 3, any number greater than 3. So greater than 3, there's 4, 5, and 6, which would be 3 out of 6 again, which is equal to 1/2. So the probability of rolling a number greater than 3 is the same as the probability of rolling an even number. Even though the numbers are different, they're still the same number of favorable outcomes, 3 and 3. So is this a fair dice? Well, thinking back to the last example, that spinner was fair because each part of the spinner was the same size and you had the same chance of getting each part of the spinner. So is this dice fair? Yes, it is fair. And why? The reason why is because each side of the dice is the same size, so you have an equally likely chance of getting either number, 1 through 6. So is this dice fair? We'll say a yes. The dice, or the die, I guess technically it's the die, is fair because the probability is the same for each number. The probability of rolling a 1 is 1 out of 6, and a 2 is 1 out of 6. Each number in the sample space would have a 1 out of 6 probability of being rolled. So that would be a fair dice. That's why, like when you're playing a game like Monopoly, you're using this kind of dice because you have a fair opportunity to get 1 through 6, and every player has that same chance. So that's why that dice is fair. All right, let's look at another situation here. Picking a marble. All right, so we have this bag of marbles here, and notice that the marbles are shaded in different ways. So how many outcomes are there? How many different marbles are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 outcomes. So let's list the sample space. The sample space is, you have the black ones, black marbles, and there are 2 black marbles. You could pick out a white marble, and there are 4 of those. And then we'll call these, I guess, striped. Striped would be 4 as well. All right, so let's take a look at some different situations here. We have the probability of pulling a white marble. Well, there's 4 white marbles out of 10. And we can divide those both by 2 to sort of simplify that probability. You could say that the probability of the chances are 2 out of 5. So a little less than half. So it's still less likely that you're going to pull a white marble. The probability of pulling a striped marble. Well, the striped ones, there's 4 of those as well out of 10, which is also equivalent to 2 out of 5. So what that might mean is if you had 5 chances to pull out a marble, 2 of those 5 would likely be striped. Now that's the theoretical probability. You'd actually have to follow through with that experiment to see if that's true. But pulling a striped and pulling a white marble, they're equal. 2 out of 5, 2 out of 5, or 4 out of 10, and 4 out of 10. Well, let's think about the black marble. For the black marble, there's 2 black marbles out of 10, which is equivalent to 1 out of 5, which is half of the probability of pulling a white or a striped, because there are less black marbles in all. Well, let's take a look at this one. This is the probability of not black. Well, if pulling out a black marble is 2 out of 10, not black would be 8 out of 10, because if there's 2 chances to get a black marble, there's 8 chances to not get a black marble. And we can see that by looking at the white and the striped. 4 tenths plus 4 tenths would be 8 tenths, or 8 out of 10, which is the same thing as 4 out of 5. And the last one says here, probability of pulling a white or a black. White or a black. So the number of favorable outcomes there is 6, because white plus black would be 6 out of 10, which is the same thing as 3 out of 5, which means you're more likely to pull out a white or a black than compared to just a striped one. All right, so is this bag of marbles fair? Well, looking at the data we have, if we look at white, striped, and black, the black has a less likely chance of being pulled. So this wouldn't be fair, a fair bag of marbles, because there's not an equal probability of picking out each color. So is this bag of marbles fair? No. The bag is unfair. And how can you tell? The bag is unfair because the probability of picking each color is not the same. So I guess the question might be, well, what can you do to make this a fair bag of marbles? There's a couple things you could do. One is you could just take out the black ones. Then you'd have striped and white, or you can add 2 black ones so you have the same amount of each color. All right, we're going to take a look at one more simple event, and then we're going to finish with a non-simple event. See that in a second. All right, so situation is picking a vowel. It says write a word with more than 4 letters where the likelihood of choosing a vowel and a consonant are equally likely. All right, so we need a word that's more than 4 letters. Now, we have to pick a word that has an even number of letters because we need to have the vowel and the consonant be equally likely to be selected. And if we had an odd number, there'd be one that was more likely to be chosen. So let's see, what's like a 6-letter word where the vowels and the consonants are the same. This can be a little tricky. Let's see. I'm thinking of the word. I think I got it. Crease. Crease came to mind. Here, let me rewrite that because I think the writing was a little smeared there. Crease. Now, the reason I chose that word is because you can see here that there are 3 vowels. So the chances of picking a vowel would be 3 out of 6. And the consonants are also 3. 1, 2, 3. And those are also 3 out of 6. It says write a word with more than 4 letters where it is more likely that you'd pick a vowel. Well, this is a little tougher one. So I'm going to pick a word that's 5 letters long. And this is a word, yeah, I'll do that one. The word is levy. You know, levy is related to controlling water, like a large body of water. So a levy is more than 4 letters, and you'd more likely pick a vowel. Like if you were just randomly select a letter out of here, the chances of picking a vowel would be 3 out of 5, and consonant would only be 2 out of 5. All right, write a word with more than 4 letters where the likelihood of choosing a vowel is 40%. Now, 40% is 40 out of 100, that's the same thing if you were to simplify that to 4 out of 10. So you could write a 10-letter word with 4 vowels. That's kind of tough, but you can also simplify this to 2 out of 5. So let's aim for that. Let's try to get a 5-letter word. So this is vowels, and this is letters. We could write a 100-letter word with 40 vowels, but I don't think we're going to find one necessarily like that. 4 out of 10 or 2 out of 5. So let's think of a word, and I see a word actually in this sentence that has 5 letters and 2 vowels, and ironically, well, not ironically, but interestingly enough, it's the word vowel. So the word vowel has 5 letters, and 2 of them are vowels, O and E. Okay, so that word would work. Vowel helped us out quite a bit in that problem. All right, last one here we're going to take a look at is a non-simple event. So this is one like this is not going to be on the quiz because, again, this is not a simple event, but flipping 2 coins. Okay, flipping 2 coins. So first thing we're going to do is list the sample space. So if you flip 2 coins, one outcome could be you get a heads and a heads. Okay, that's one outcome. The other one, another one, could be you get a heads and a whoop on one and a tails on the other. The third outcome is you get 2 tails. The pen's going crazy now. And then the fourth outcome would be you get a tails on the first coin and a heads on the other coin. So really there are 4 outcomes. So if we look at these possible outcomes, what is the probability of flipping 2 heads? Well, we have 1 chance of getting 2 heads out of 4. what are the chances of flipping 2 tails? Flip 2 tails, you get one outcome out of 4. Last but not least, probability of flipping a head and a tail. There are 2 outcomes out of 4. So this is, which is equivalent to 1/2. So this is the more likely outcome, is that you're going to get a head and a tail. You're going to get that half the time. So it's equally likely that you'd get a head and a tail compared to getting 2 of the same. Okay, so that's called a non-simple event. We're not really going to take a look at those type of events anymore this year, but I just wanted to show you that some events are not necessarily simple, and that the sample space is just a little bit more difficult to find. All right, well, I hope you enjoyed looking at some simple events. If you have any questions, please let me know. But I hope you have a great day, and I'll see you soon. Okay, bye-bye.